Hello class, today we are taking a look at section 10.4, which is other angle relationships in circles. The first theorem we're going to take a look at today, we've got several theorems. The first one says that if a tangent and a chord or a secant intersect at a point on a circle. Now if a tangent is intersecting something at a point on the circle, that's got to be the point of tangency. So if a tangent and any other segment that's going through the circle intersect at that point of tangency, then the measure of each one of these angles, angle 1 and angle 2, that's formed, will be half of the measure of their intercepted arcs. Now, if you think about this, this sounds a lot like our inscribed angles theorem that we took a look at the other day. The difference is that here, my two sides of my angles are not both parts of chords. Here I've got part of a chord and part of a tangent line. But the same idea is true. So if I want to talk about the measure of angle 1, it is going to be half of the measure of its intercepted arc. So half of the measure of arc AB. Now, same idea, I should say, is true with the measure of angle 2, that it is half of the measure of this arc over here. Now notice this arc is a major arc, so we do need to list it with 3 letters. So we're going to say the measure of arc. And it doesn't matter if you want to say ACB or BCA, but half of that arc will give you that intercepted angle. All right, next. If two chords or secants intersect in the interior of a circle, so notice here I've got two chords that are intersecting inside the circle, then the measure of each angle is going to be 1/2 of the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, so what this is saying, if I'm trying to figure out the measure of the, let's just say the measure of arc, or measure of angle 1. If I wanted to figure out the measure of angle 1, that measure of that angle will be 1/2 of the sum of the measures of its arc and its vertical angle's arc. So 1/2 of, I could say, the measure of arc CD plus the measure of arc AB. So it's half of the sum of its arc and its vertical angle's arc. Now, measure of angle 2, no, measure of angle 3 would be the exact same thing because its arc and its vertical angle's arc are the exact same angles, or exact same arcs as what the measure of angles 1's arc and its vertical arc would have been. Now, the measure of angle 2 would be half of the measure of its arc, arc BD, and its vertical angle's arc, arc AC. Measure of arc AC. So when, and by the way, the measure of angle 4 would have been exactly the same thing because we'd be talking about then its arc, this AC, and its vertical angle's arc. Whenever you're taking a look at an angle that's inside of a circle, you'll see this relationship. Now, the rest of these theorems are talking about when your angle is outside of the circle. There's 3 parts to this theorem. The first one being when you've got a tangent and a secant. But really the same relationship is going to happen on all of these. When you've got an angle that's outside of the circle, the measure of that angle will be 1/2 of the difference. 1/2 of the difference of really the major arc and then the minor arc. So it's 1/2 of the larger arc, so the measure of arc CDB, the difference between that and arc CA, the measure of arc CA. All right, this next theorem is talking about two tangents that are intersecting in the exterior of a circle. Then the measure of the angle that's formed, so this measure of angle 2, is 1/2 of the difference of the measures of the intercepted arcs. So 1/2 of the difference between, again, the larger arc minus the smaller arc. So we're going to do the measure of PQR minus the measure of arc PR. So same idea. Again, whenever you notice that there's a point outside, we're doing a difference. It's half of the difference between the two arcs that you'll see. Now, this last theorem, this last part to this theorem, I should say, is talking about two secants. So again, now you'll notice that they're intersecting in the exterior of the circle still, but this time they're both secants. So now we no longer have a tangent involved. We have two rays, in this case, that are going to intersect the circle at two places. But again, the same idea is true. It says that the measure of the angle that's formed, so in this case the measure of angle 3, is 1/2 of, again, the difference in the measures of the two intercepted arcs. Again, the larger one minus the smaller one. So the measure of arc XY minus the measure of arc WZ. Again, just kind of in general, when you had a point that was inside the circle, we did half of the sum of those two arcs, of its arc and its vertical angles arc. When you have a point that's in the exterior, wherever that is, if it's formed by two tangents, by a tangent and a secant, or by two secants, it's going to be half of the difference. So inside we'll be adding the two arcs. Outside we're going to be subtracting the two arcs.